Hello, Professor Fu. Yes, absolutely. Do you remember this? Do you remember this? Mayo, Mayo lead. Mayo lead for Canon camera.
Our team getting bigger, and you can see the full room of students. And this is all is within our group. Our group, I think, nearly 100 people. So we like to continue work with you guys. Okay, next we will come Professor Paul from Poland.
Hello, everyone. Good morning or good afternoon, depends on the place that you are living. Okay, can you see my screen? Okay, so may I start? I hope that I may start my talk. Once again, good morning and good afternoon. Uh, my presentation is a little bit uh, different from the previous one. That was fantastic talk. Mm, it is divided by or it's split into two parts. The first one is focusing on research on small sailing yacht about sailing itself, and the second is focused on nanomaterials that can be used for um, analytical devices, small analytical devices that can be attached to the small vessels and do the measurements in remote places. So all of the information, mm, one second, you may find on my YouTube channel, which is a little bit eclectic and contains number of short video movies, which are, I may say, like parody or comedy, but the topic is very serious. Is overall goal is new devices for analytical chemistry and all actions that I did to do this. Mm, I may start my presentation. Uh, I would like to say that people are spending a lot of money for pleasure. For example, the most expensive sailing yacht is History Supreme. It's worth $5 billion. Some of the people would like to have a speed boat like Spirit of Australia. Uh, the modern sailing is also uh, focused on new technology. So we may see the hydrofoils or the concepts of very speed, very fast vessels based on Polynesian yachts like Sail Rocket 2, and all of the sailing yachts or motor yachts are expensive, but also they are very extremely dangerous. There's nothing more danger than sailing yachts, modern sailing yachts. But for thousands of years, the people used very small boats. Even now, you may see different concepts like uh, monohull sailing yachts or multi-hull sailing yachts, and they can be used for not only for pleasure, they can be used for research, like Tara yacht or Tara expeditions. They are sailing around the globe and collecting data, or Gaia's Dream, which is an example of proa yacht that may operate as a research vessel. However, my focus is very small sailing yachts. What it means very small? Like 3, 4, 5 meters long, and there are a number of people that building such small yachts, boats. Like in Poland, it's well known boat sailing yacht constructor Janusz Ostrowski, Sven Irwin, which is extremely interesting person. He is doing the trips around the globe, and now he is over 80 and is building the small boat. There is also a community of people that enjoy sailing, like Roger Barnes and his dinghy cruising association. I'm personally interested to build small sailing yachts, and I selected 2 of them. They may be used for inland waters as well, for Baltic Sea, which is a little bit nasty aquatic environment. So from the left side, from the top of this slide, you may see the Pomeranka, which is dinghy, small dinghy, and bottom, this is also small sailing yacht, 5-meter long Setka. However, to build these vessels, I have to learn a lot, and at this moment, I'm doing small dinghy Passia 400. You can see this on my YouTube channel, the progress of the work with this small dinghy. Oh, sorry. There is something wrong with my presentation. There is a number of aspects for sailing. One of the problem is the sail itself, and I finished the project, which was called Igua Needle. This is the proa yacht, sailing yacht with very flat sail. This sail is crab claw sail, which is an example of very efficient sail that can be used for small sailing yachts. And obviously we are doing a lot of expeditions using classical sailing yachts. This is 12-meter boat, and we did a few expeditions on the Baltic Sea to collect number of environmental samples, and this was a starting point for or this will be starting point for my next research. The concept is you may see the problem here. This is the traffic density map that can be found on the marine traffic webpage. So you may see how many vessels are running through the Baltic Sea. And you may also imagine that all of them can produce number of pollutants, low molecular mass compounds that can be considered as pollutants. Also, we may, in the future, we may try to attach to each vessel small device that can be a sensing device and collect number of data, and then we may check the condition on changes of conditions of sea environment. And now this is probably more interesting part for the meeting. What we did for the last few years. First of all, we were interested in biopolymers that may work as absorbing matrix for micropollutants, and also as the stationary phases for microplanar devices for quantification of micropollutants from water. There are a number of approaches how to extract the pollutants from the water ecosystems, and so far we tested dandelion pappus. It is very interesting natural biopolymer that can attract in selective way. The dandelion pappus can absorb micropollutants from water. Also, we tested cellulose which was coated with graphene oxide. The problem is that for a few years there is extensive research focused on small analytical devices, and the results of quantification of results that are coming from such of object can be easily photographed and then analyzed in remote places. So we are trying to do such of devices, and also we will try to apply fairly complex data analysis system, which is based on voxel correlation images. So what we need the signal which is unstable in time. Then we may do number of mathematical calculations, including Fourier transform, and get complementary information that is based on the contrast images in frequency domain and so on. This is very useful, and this may increase overall sensitivity of for detection few factors. Most recent research is focusing on the quantum dots. We found that those objects, fluorescence from those objects on the planar chromatographic stationary phases are unstable. That is very good for voxel correlation images, and even using classical fluorescence, we may see the increase in detection for a small amount of micropollutants that are present in water. Also, we tested number of materials like, as I mentioned, dandelion pappus. This is picture E, but also the pollen, and also the Egyptian blue, nanomaterial and graphene oxide, as well as cyclodextrins. So number of nanomaterials that can be used for small analytical devices. And also we found that some of them are unstable, which is necessary to get the signal for voxel correlation images. As the summary of this talk, I would like to say that we collect number of samples, and the preliminary analysis of such samples clearly indicate that this approach can be useful for object classifications, in our case waters classifications, using very small fraction of money that people usually are spending for doing such research. So if you would like to see what's going on with the RoSSY project, please subscribe my channel, YouTube channel, and be in touch. Thank you so much for your attention.